in this video I am going to explain about worksheet questions of solutions and colligative properties. Here first question. A solvent freezes at 17 degrees centigrade and has latent heat of fusion 180 joules per gram. The molar depression constant of solvent is. That is simple question. Molar depression constant Kf equal to RTF square by 1000 into LF. So where LF is again delta HF by molecular weight of solvent. So this is the formula to calculate molar depression constant. So therefore Kf equal to, substitute the values, R value in joules 8.314 TF, freezing point. So freezing point 17 degrees, that is 290 square by 1000 into LF 180. So from this we'll get value 3.88 Kelvin kg per mole. So option A, 3.88. Next question. The freezing point of equimolar aqueous solutions will be highest for. Simple question. So freezing point of solution, here minus freezing point of solution directly proportional to I. So freezing point should be highest here, therefore I should be least. So if I value decreases, freezing point of solution increases. So therefore in given options C6 H12O6, I value 1, which is lowest value. Therefore C6 H12O6 solution has highest freezing point. Option D. So here I value 2, here I value 3, here I value 4, here I value 1. So as the value of I decreases, freezing point increases. Next. Which of the following substances show the highest colligative properties? So we know colligative property directly proportional to any colligative property directly proportional to I, which is Van 't Hoff factor. Van 't Hoff factor. So as the value of I increases, colligative property increases. Therefore, for NH3, not NH3, NH4 thrice PO4, it dissociates to 3 NH4 plus PO4 3 minus. Therefore, I value equal to 3 plus 1 4, which is highest value. So for BaCl2, I value is 3. Ba2 plus 2Cl minus. For this I value is Az plus NO3. I value 2. So for this I value 1. So for this I value is 4. So therefore it has highest colligative property. So highest Van 't Hoff factor means highest colligative property. Option D. That depends on number of particles of solute. Next. So which of the, that means what is the effect of external pressure on osmotic pressure of solution? So osmotic pressure depends on concentration of solution. Concentration means you can take it as molarity. According to equation, osmotic pi equal to I into CST. So I depends on concentration C. Pi depends on concentration C. So therefore, osmotic pressure remained nearly same with increase or decrease of external pressure. Option C. That means pi is independent of external pressure. Independent of external pressure. So option C. Pi depends only on concentration, that is molarity, independent of external pressure. Therefore, it becomes nearly same with increase or decrease of external pressure. Next. Henry's law is valid for Henry's law. So, to obey Henry's law, there should be no reaction between gas and solvent. So, here there should be no reaction between the gas and the liquid. So therefore, O2 in H2O, so which is C, and D. CO2 in H2O, Henry's law is valid. Therefore, option C and D. So ammonia gas dissolved in water means there will be chemical reaction between ammonia gas and water, highly soluble. Ammonia is highly soluble in water due to hydrogen bonding formation. So O2 dissolution in blood, that is also highly soluble. O2 is highly soluble. So therefore for C, D, we can apply Henry's law. Next. At 0 degrees centigrade, urea solution has osmotic pressure 400 mm. On dilution by X times, its osmotic pressure decreased to 100 mm at 20. The dilution factor X approximately. So here two conditions. Take first pi 1 equal to C1 or T1. That means pi 1 400. 400 equal to C1 or, so T1 is 0, that means 273. Say expression 1. Next, pi 2 equal to C2 or T2. So this is 100. C2 or, so second temperature 20, therefore 293. Expression 2. Therefore 1 by 2 gives, so 400 by 100 equal to, so C1 into 273 by C2 into 293. And here it is given. So dilution C2 is C1 by X. So with dilution, concentration decreases. So from this we'll have So 4 equal to, in case of C1 we can write C2 into X to 273 by C2 into 293. So therefore we'll get X value as 4.29, approximately 4.3. 4.3, option A. So dilution 4.3 times. Next. So on mixing urea, the boiling point of H2O changed to 100.5 degrees. Calculate the freezing point of solution. Kf and Kb of water are given. So simple question only. Relation between delta Tf and delta T. So we know delta Tb by delta Tf equal to Kb by Kf. We can write like this. So here delta Tb elevation is 0.5. So 100.5 degrees minus 100 by delta Tf equal to Kb value 0.52 by 1.87. So from this delta Tf is 1.8. So therefore freezing point of solution equal to minus 1.8 degrees centigrade. Therefore option C. So because delta Tf is freezing point of solvent minus freezing point of solution. So freezing point of solvent we know 0. Therefore delta Tf equal to 0 minus freezing point of solution. Remember this. Therefore freezing point of solution minus of delta Tf value, minus 1.8 degrees. Next, the freezing point of an aqueous solution containing 25 grams of ethanol in 1000 grams of H2O is. So freezing point of solution we can find here. So first delta Tf equal to Kf into molarity, that is Kf into molarity Wb by Mb into 1000 by Wa. So B is for solute, P is for solute and A is for solvent. So therefore delta Tf equal to Kf value 1.86 into weight of solute 25 by 46 molecular weight into 1000 by 1000. So these two gets cancelled. So therefore delta Tf equal to 1.01. Therefore freezing point of solution equal to minus 1.01 degrees centigrade. So minus 1.01 is approximately 1 degree centigrade, minus 1 degree. Therefore option D, minus 1 degree centigrade. Next, solution A. So phenol, solution A, phenol plus aniline. Solution A is phenol plus aniline, which shows negative deviation. Negative deviation from Raoult's law. So due to attractive forces. Next, chloroform CHCl3 and acetone CH3COCH3. So here also due to interactions negative deviation. So both are examples for negative deviation. Therefore option B. So here A, B interactions are more. That means between phenol and aniline interactions will be more. Between chloroform and acetone also interactions will be more. Therefore both are showing negative deviation. Next. The vapor pressure of pure water is 23 mm. Vapor pressure of aqueous solution which contains 10 mole percent of solute A having molecular weight 50. 10 mass percent. So a 10 mass percent means 10% weight by weight means 10 grams of solute present in 90 grams of solvent. Total solution must be 100 grams. Therefore, relative lowering of vapor pressure P0 minus Ps by P0 equal to, so Wb by Mb into Ma by Wa. So W means weight, M is molecular weight. Therefore, from this P0 is 23 is given, Ps by 23 equal to weight of solute Wb 10 by molecular weight 50 into molecular weight of water 18 by 90. So from this we'll get Ps value as 22.08 mm. Therefore, Ps in atmosphere is equal to 22.08 by 760 atmospheres, which is equal to 0.029 atmospheres. So we know relation. So 1 atmosphere equal to 760 mm of H relation. So therefore option D 0.029 approximately. Next. The freezing point depression of 0.001 molar of AXB by FeCN6 is, it is given depression freezing point. Next, the oxidation state of iron is +2 and Kf, here Kf should be there, not Kr, Kf. Kf equal 1.86, then total number of possibilities for different types of AB cations are. So simple question only. So first here molarity is given 0.001. I am taking molarity as molarity here. Next, delta Tf is given 5.58 into 10 power minus 3 kelvins. Kf value 1.86. So from this we can calculate I value. I value is delta Tf by Kf into M. So delta Tf 5.58 into 10 power minus 3 by Kf value 1.86 into molality 0.001. So we'll get this value as 3. Very important. So therefore number of possibilities for different types of A and B cations equal to 3. So very important. That means simply I value. Next. Calculate depression freezing point of a solution containing 0.1 gram of K3FeCN6 and 100 grams of water. That's a simple question and direct question. So delta TF, we can find delta TF equal to, so I into KF into M. So I into KF into M means WB by MB into 1000 by WA. So therefore delta TF equal to I value 4 because K3 FeCN6 dissociates to 3K plus 3K plus Fe CN6 3 minus. So here I will write I value equal to 4. Very important dissociation. K3 FeCN6. So I value equal to 3 plus 1 4. So here ions will be 3K plus FeCN6 3 minus. I value 4. So therefore delta TF equal to I value 4 into KF value 1.86 into weight of solute 0.1 by molecular weight is given 329 into 1000 by 100. So from this we'll get delta TF equal to 0.0226. Option C. So kelvins or degrees centigrade we can say. Next. Molality of 1 mole of solute in 50 grams of solvent is. So molality is number of moles into 1000 by weight of solvent in grams. Therefore M equal to, so N is number of moles of solute, 1 mole is given 1 into 1000 by weight of solvent in grams. That means 1000 by 50 which is 20. So 20 molal or moles per kg. So 20 is the answer. Next. So at T kelvins, the partial pressure of dissolved oxygen is 1 bar in 1 liter. The concentration of oxygen in ppm is. So very important question. So here it is given partial pressure of O2. Partial pressure of O2 is 1 bar. Next, KH value is the Henry's law constant 50 kilobar, which is equal to 50 into 10 cube bar. Next, volume 1 liter, that is 1000 ml. So that is equal to 1000 grams because density of water is 1 gram per cc. Density for water. Next, according to Henry's law, partial pressure equal to KH into mole fraction of O2. So from this mole fraction of O2 equal to PO2 by KH. So here PO2 is 1 bar by kh, 50 into 10 cube bars. So that is 1 by 50 into 10 power minus 3 mole fraction. Next, again mole fraction equal to number of moles of O2 by number of moles of O2 plus number of moles of water, equal to 1 by 50 into 10 power minus 3. So number of moles of O2 can be neglected. Therefore, number of moles of O2 equal to, so 1 by 50 into 10 power minus 3 into number of moles of water. Here we can say number of moles of water equal to weight 1000. 1000 by 18. So which is 55.5 number of moles of water into 55.5. So therefore we'll get value number of moles 1. Number of moles of water equal to 1.11 into 10 power minus 3. Therefore ppm equal to 1.11 into 10 power minus 3 by 10 cube. That means weight of solute by weight of solution into 10 power 6. That is equal to 1.11. This will be the answer. Here wrong is given. So therefore change B option as B option 1.11. Very, very important. 1.11. Option B. Weight of solute. That means number of moles. So once check here. So option correct only here. 35.5 only. Check here. Number of moles of O2. Got here 1.11 into 10 power minus 3. Here moles. So convert it into weight. So therefore weight of O2 equal number of moles into molecular weight into 32. Therefore it will be weight of O2 is 35.52 into 10 power minus 3 grams. Therefore ppm is equal to weight of oxygen by weight of solution. Weight of solution 1000 grams 10 cube into 10 power 6, 35.52. Therefore option B. So this one correct only. We have to convert moles into weight. Next. So which are the following has highest freezing point? Highest freezing point. Take here for KCl. For KCl, I value equal to 2. For K2SO4, I value equal to 3. So both are having I value greater than 1 due to dissociation. Next. Therefore, freezing point of I greater than 1 is freezing point of solution decreases. So since I value increases, freezing point of solution decreases. So this is very, very important. Next. So delta TF for urea KF into 0.1 into 1000 by 1000. So this is for urea solution. So which is equal to 0.1 into KF. KF is constant. Next, delta TF for glucose. Delta TF for glucose equal to KF into again 30 by 30 grams by 180, which is equal to 0.1 So 0.166 into Kf. So delta Tf is this one 0.1 Kf. This is highest freezing point. Therefore, option C. So a lowest value, delta Tf lowest means freezing point of solution will be highest. This is the lowest value. Lowest delta Tf means highest freezing point. So which are the following pairs of solution is isotonic. Isotonic. So isotonic solution means phi 1 equal to phi 2. Two solutions are said to be isotonic if they have same osmotic pressure. That is very important. So take option A first. So isotonic condition is W1 by V1 M1 equal to W2 by V2 M2. So here take I1 and I2 if ionic compounds are present. So that implies glucose and urea are having I value 1. Therefore 18 by weight is 18 by volume 1000 ml into molecular weight 180. Next that is equal to 6 by again 1000 volume by 60. So therefore 0.18 by 180, 0.1 and 0.1. So this is pi 1, pi 2. Both are same. Isotonic condition. Next, option C. Similar 0.01 molar. That means 0.01 into 2. This is for NaOH, Na plus and OH minus. Next, for this 0.02 into 1. So for NaOH I value 2. For glucose I value 1. So therefore 0.02 equal to again 0.02. This is pi 1 and pi 2. So both are same. A and C are having same osmotic pressure. Therefore option B. So this is for glucose and this is for urea. Next this is for NaOH and this is for glucose. Very important. Next. X% weight by volume solution of urea is isotonic with 4% of weight by volume of non-volatile solute of molar mass 120. The value of X is. So here I am taking urea with non-volatile solute. Non-volatile solute. So isotonic means say this is pi 1, this is pi 2. Therefore W1 by M1 V1 equal to W2 by M2 V2 isotonic condition. Here X by molecular weight is urea 60 into 100. Next here 4 by molecular weight 120 is given, 120 into volume 100 again. So therefore 100 cancel. Therefore X value equal to 60 into 4 by 120. So which is equal to 2. Option A. Next. So blood is collapse when suspended in saline water. So we know blood is isotonic with 0.9% of NaCl. We know blood is isotonic with 0.9% of NaCl. So blood cells collapse when suspended in saline water. So if 0 point, that means greater than, NaCl is greater than 0.9%, then solvent molecules blood and take NaCl. So water is moving from, that means solvent is moving from here more concentrated. More concentration means more osmotic pressure, more pi value. Therefore, water molecules flowing from blood into NaCl. Therefore, shrinking takes place, collapse. Next, if NaCl concentration less than 0.9%, less concentration, therefore less osmotic pressure. So therefore in this water is moving from NaCl to blood, H2O migration. So therefore blood cells collapse when suspended in saline water. Next, so statement 1 correct. Next, cell membrane dissolves in saline water. That is incorrect. Therefore reason correct. The assertion is correct, reason is not correct. Therefore option C. So very important. So saline water has more concentration of NaCl. This is saline water. Saline water has more concentration of NaCl. That is greater than 0.9%. Therefore water is moving from blood into NaCl. Therefore blood vessels collapse. Next, cell membrane dissolves in saline water is given. So here blood vessels swells up. So option C. Next, the KH values for argon, CO2, formaldehyde and CH4 are given. We have to find solubility. So as the KH value increases, solubility of gas decreases. As the value of KH increases, temperature also increases, solubility of gas decreases. So therefore first order KH values, KH value order is, so argon highest, next CO2, next CH4, next formaldehyde. So therefore solubility order is argon less than, CO2 less than, CH4 less than, HCH4. So option D, argon, CO2, CH4 and formaldehyde. Next, so which of the following will form an ideal solution? So ideal solution will be formed by benzene plus toluene. These can form ideal solution. So here benzene means take B, toluene means take T. So interactions between BT interactions equal to BB interactions and TT interactions. So all are having almost identical interactions. Therefore, they can form ideal solution. Interaction between benzene and toluene will be equal to benzene and benzene. That is also equal to toluene and toluene. Therefore, option D. Next, the molarity of 0.2 normal Na2CO3 solution is. So, normality equal to molarity into n factor. So, therefore, molarity equal to normality by n factor. So, normality is 0.2 by n factor 2. For Na2CO3, 2 Na plus CO3 2 minus. So n factor is 2 for Na2CO3. Therefore 0.1 molar. So option C. Next, the solubility of AgBr with solubility product 5 into 10 power minus 13 at 298 kelvins in 0.1 molar NaBr is. So AgBr, sparingly soluble salt, Ag plus and Br minus, initially solubility SS. So therefore Ksp equal to S into S, that is Ag plus into Br minus, which is equal to 5 into 10 power minus 13 initial value. So in 0.1 molar NaBr, that is equal to, here Br minus concentration 0.1 molar. Br minus concentration equal to 0.1 as well as Na plus concentration also same. So therefore Ksp equal to, so S into concentration of Br minus increases 0.1. Therefore it will be S square plus 0.1 into S. S square can be neglected, higher powers. Therefore S equal to Ksp by 0.1. So 5 into 10 power minus 13 by 10 power minus 1. Therefore 5 into 10 power minus 12 molar. So option B. Therefore solubility decreases due to common ion. Next. So 160 grams of non-volatile solute A is dissolved in 54 ml of water at 373 kelvins. So what is the vapor pressure of aqueous solution of A? Vapor pressure of aqueous solution of A. Simple question only. So 373 kelvins means take P naught as 760 mm of Hg or 760 torrs. Both are same. So next, P naught minus Ps by P naught equal to, so Wb by Mb by Wb by Mb into, not into, plus Wa by Ma. So P naught, on substituting P naught value 760 minus Ps by 760 equal to, so weight 160 grams, 160 by molecular weight also 160 by, here also 160 by 160 plus 54 grams, 54 by 18. So from this we'll get 760 minus PS by 760 equal to 1 by 1 plus 3, that is 1 by 4. So therefore PS is 570 torque. Option C. Next, 10 grams of NaOH is dissolved in 500 ml of aqueous solution. So molarity given weight of solute in grams by gram molecular weight of solute into 1000 by volume of solution in ml. Therefore m equal given weight 10 by gram molecular weight 40 into 1000 by 500. So this will be 2 times. This will be 4 times. 2 by 4. So which is 1 by 2, that is 0.25 molar. Option D. Direct question. Next question. If aqueous solution contains 9% and 1% of two non-volatile non-electrolytes with molecular weights 180 and 50 respectively, boiling point of solution. So that is delta TB first. Elevation in boiling point equal to, so Kb into molarity. So in place of molarity we can write number of moles into 1000 by weight of solvent. Number of moles means here 9 by molecular weight 180 plus here 1% 1 by 50 into 1000 by weight of solvent. So weight of solvent percent means here take 100 percentage 100 ml, that means 100 grams. So delta TB equal to Kb 0.52 into, so this value 9 by 180 plus 1 by 50 into 10 times. So we'll get delta TB at 0.36. Therefore boiling point of solution minus boiling point of solvent equal to 0.36. So boiling point of solvent is 100 degrees centigrade. Therefore boiling point of solution equal to 100.36 degrees centigrade, which is equal to 100 point approximately 4 degrees centigrade. Option B. Important question. Here two solutes are given. Two solutes. I am taking here total number of moles of two solutes. Next. A solution is prepared by dissolving 10 grams of non-volatile solute with molecular mass m in 360 grams. 360 grams of water. What is the molar mass in grams per mole? That means relative lowering delta P by P naught equal to, so relative lowering vapor pressure is given delta P by P naught, WB by MB